What if I told you that the garbage you threw out this morning could power your home tonight? That your leftover pizza box and banana peel could keep the lights on for 300,000 apartments? Welcome to the revolution happening in waste management, where trash isn't just trash anymore. It's fuel. It's energy. It's the future. Let's talk about a problem we're all creating every single day. The world generates over 2 billion tons of solid waste annually, and that number is exploding as cities grow. But here's the real kicker. We're running out of places to put it. Traditional landfills aren't just ugly, they're environmental time bombs. When organic waste decomposes without oxygen, it produces methane, a greenhouse gas 25 times more potent than carbon dioxide. But simultaneously, the world needs to triple its renewable energy capacity by 2050 to keep global warming under 1.5 degrees Celsius. So we have two massive problems: mountains of waste and an energy crisis. What if the solution is to solve both at once? Enter waste to energy, or WT. It's exactly what it sounds like, converting garbage into electricity, heat, and fuel. But this isn't some futuristic fantasy. It's happening right now, all over the world. The global waste-to-energy market is currently valued at $38.8 billion and is projected to more than double to $86.8 billion by 2035. Europe leads the charge, handling over 41% of the global market, while Asia-Pacific is the fastest-growing region as cities like Shanghai, Mumbai, and Jakarta scramble to manage waste from hundreds of millions of new urban residents. But here's what makes WT special. Unlike solar panels that only work when the sun shines, or wind turbines that only spin when the breeze blows, waste-to-energy provides baseload power. Consistent, reliable, dispatchable. It's renewable energy you can count on 24/7. So how do you turn a banana peel and a plastic bottle into electricity? There are actually several pathways, each designed for different types of waste. The workhorse of the industry is thermal conversion, essentially controlled burning at extremely high temperatures. Modern mass-burn incinerators can reduce 2,000 pounds of trash to just 300 pounds of ash. That's an 87 to 90% volume reduction. Here's how it works. Waste is fed onto moving grates inside a combustion chamber heated to over 1,100 degrees Celsius. The intense heat generates steam, which drives turbines to produce electricity. Modern plants can even capture residual heat for district heating systems, powering both homes and businesses. In Europe alone, 10% of district heating energy comes from waste-to-energy plants. That's millions of homes staying warm without burning fossil fuels. But the technology doesn't stop there. Gasification takes things to the next level. By heating waste between 700 and 1,500 degrees with limited oxygen, we break it down into syngas, a mixture of hydrogen and carbon monoxide. This can be burned for electricity with higher efficiency or even refined into transportation fuels. And then there's plasma arc gasification, the most extreme method. Using a plasma torch that reaches up to 5,000 degrees Celsius, this technology essentially vaporizes waste into its elemental components. We're talking 99% waste to syngas conversion. What's left? An inert, glass-like slag that can be used in construction. It's like turning trash into building blocks. For wet organic waste, think food scraps, agricultural residues. There's a gentler approach: anaerobic digestion. Microorganisms break down organic matter in oxygen-free tanks, producing biogas that's primarily methane. This biogas can generate electricity or be upgraded to biomethane and injected directly into natural gas pipelines. The bonus? What's left over is nutrient-rich digestate, essentially a natural fertilizer that can replace energy-intensive synthetic fertilizers. Want to see the future? Look at Singapore. Singapore's Tuas Nexus is the world's first integrated waste and water facility. Think of it as the ultimate circular economy showcase. In a country where land is more precious than gold, they've co-located a water reclamation plant with a massive waste management facility. Here's where it gets brilliant. The facility handles 4 waste streams simultaneously: 5,800 tons of regular trash per day, 250 tons of recyclables, 400 tons of food waste, and 800 tons of sludge from water treatment. But the real genius is in the synergy. They co-digest food waste with water treatment sludge. The microbes go into overdrive, producing significantly more biogas than either stream would generate alone. That biogas is then used to boost steam temperatures in the incinerators, increasing electricity generation. The result? The entire facility is energy self-sufficient and exports enough electricity to power 300,000 homes. It saves 2.6 hectares of land and prevents 200,000 tons of CO2 emissions annually. This isn't just waste management, it's urban metabolism engineering. Now, let's address the elephant in the room. Waste-to-energy isn't without controversy. The biggest concern? Emissions. Historically, incinerators release toxic pollutants, dioxins, furans, heavy metals. These are serious health hazards. But modern facilities are nothing like their predecessors. Today's plants use multiple defense layers, secondary combustion chambers that completely destroy organic pollutants, rapid cooling systems to prevent chemical reformation, activated carbon injection to capture heavy metals, and high-efficiency filters. The result? Emission levels often cleaner than natural gas power plants. The 2024 EU Industrial Emissions Directive has raised standards even higher, requiring real-time monitoring and electronic permits by 2035. Then there's the cost. Building a waste-to-energy plant isn't cheap. A facility handling 1 million tons annually can cost $1.2 billion upfront. These require 15 to 20-year contracts with municipalities just to become financially viable. But here's the counterpoint. Unlike solar or wind, WT facilities provide both a waste disposal service and energy. They charge gate fees, typically around $50 per ton of waste processed. Combined with electricity sales, recovered metals from ash, and increasingly, carbon credits, the economics can work. The U.S. Inflation Reduction Act now offers up to 30% tax credits for facilities that export waste heat, adding 2 percentage points to project returns. But the real future of waste-to-energy isn't just about burning trash, it's about closing the loop entirely. Take the ash left over from incineration. In Europe, 54% of bottom ash is already reused in civil engineering. It can replace up to 40% of aggregate in road construction, and studies show it actually improves pavement performance. Modern facilities also extract thousands of tons of aluminum, copper, and zinc from ash annually. And remember that digestate from anaerobic digestion? It's packed with nitrogen, phosphorus, and potassium, essential crop nutrients. Countries like the UK are increasingly using it to replace mineral fertilizers, which are incredibly energy-intensive to produce. Here's where it gets really exciting. Because 50 to 60% of the carbon in municipal waste is biogenic, meaning it comes from plants and food, waste-to-energy with carbon capture could actually be carbon negative. Pilot projects are already running in Oslo, the Netherlands, and Japan. Singapore is launching its own carbon capture pilot by 2026. If scaled globally, this could transform waste-to-energy from low-carbon to climate-positive. So where does this leave us? Waste-to-energy isn't a silver bullet. We still need to reduce consumption, improve recycling, and prevent waste at the source. But in the real world, waste will always exist. Urban populations are growing. Landfill space is disappearing. Energy demand is rising. The question isn't whether we should manage waste. It's how intelligently we can do it. Modern waste-to-energy facilities are engineering marvels, producing clean electricity, recovering valuable materials, reducing emissions, and even becoming architectural landmarks. Some, like Copenhagen's Copenhill plant, feature ski slopes and climbing walls. They're transforming from industrial eyesores into community assets. The global transition to a 1.5-degree future requires us to rethink everything, including what we throw away. Waste-to-energy is proving that in the circular economy, there's no such thing as garbage. There's only resources we haven't figured out how to use yet. If you found this fascinating, hit that like button and subscribe for more deep dives into the technologies reshaping our world. Check out the description for sources and further reading. And here's a question for the comments. Would you support a waste-to-energy facility in your community? What would make you say yes or no? Let's discuss. Thanks for watching. Until next time, remember, your trash might just save the planet.